Good morning. Are you all able to hear me? Good morning. Are you all able to hear me? Is my video clear? Is my audio clear? Good morning, everyone. How are you all? Let me see who all are present today. Let me check. Yes, very good morning to everyone. Good morning, Abhinash. Good morning. Yes, let me just check who all are present. Yes. All right. Great. Good morning, Shini. Good morning. All right. So let me just start by introducing you all to Unacademy, India's largest education platform. This is Let's Crack NEET UG English platform. We'll be studying English in this platform. All right. Let me introduce myself. I am Nitesh Devnani. I have 5 years of teaching experience in chemistry and I have taught over 2000 plus students who have got some great marks in your NEET examination. All right. Yes. So this is your let me tell you about the benefits if you buy the subscription plan. This is, first of all, you need to download this Unacademy learning app. Just download this Unacademy learning app. All right. Yes, see, there are two types of subscription. First is the plus subscription. Plus subscription means you'll have daily live classes, you will have live test and live quizzes, there are structured courses, as well as you'll have unlimited access in the plus subscription. Another type of subscription you have is iconic subscription. Now see now see you'll be getting all the benefits of plus subscription. All right, first of all, you'll be getting all the benefits of plus subscription. In addition to that, you'll be given a personal coach. All right, you'll have some test analysis, like what are your weak points, you can then focus on it. You'll have a study planner also. All right, and all the benefits of plus you'll be getting it. These are all in iconic subscription. Okay, so in the plus subscription, you have India's best educators, interactive live classes, you have structured courses and PDF, as well as live tests and quizzes. All right, in the iconic subscription, you have all these things, as well as you'll be given a personal coach also. You'll have a study planner, you'll have experts guidelines, as well as a test analysis. All right, these all are in the iconic subscription. Okay, so see, there are free classes also, free live classes also. You just need to download Unacademy learning app. You need to download this in order to access these free classes also. All right. Yes yes so see, these are some of the educators in our NEET platform. Now let me tell you about the pricing for the iconic subscription. For the iconic subscription, you have 6-month course at 34,200, 12-month course at 58,500, and 24-month course at 90,000 rupees. All you need to do is just apply this code Nitesh YT. Just apply this code Nitesh YT and you'll be getting 10% off. All right, whenever you plan to buy the subscription plan, just apply the code Nitesh YT. All right, let me tell you about the plus subscription. Again, you need to apply the code Nitesh YT in order to have your 10% off. All right, again, after the 10% off, 12, I would recommend you to go for either 12-month course or 24-month course. If you are in 12th, or if you are a dropper, then go for 12-month course, or if you are an 11th standard, then go for 24-month course. All right, 12-month course you'll be getting at 34,650 rupees, and 24-month course you'll be getting at 50,400 rupees. After you apply this code Nitesh YT, then only you'll be getting at these prices. All right. Okay, great. So these are some of the benefits of our plus subscription. We have already discussed this. Yes, great. So this is Atomic Structure Lecture 7. This is Atomic Structure Lecture 7. Fantastic. Let me see who all are present in the chat section. Just wait. Just please wait. Let me just check. Yes. Let me just check, guys. Please wait. Yes. All right. So this is atomic structure lecture 7. Lecture 7 we are going to discuss. Yes. Hello Keshav, how are you? Hello Srinivas. We are already doing everything in detail only. Hello Binash. Hello Shini, how are you? All right, all right, all right, all right. Just give me a thumbs up. Yes. Good morning, Rahul. Good morning. Good morning, Srinivas. Good morning, Keshav. Yes. This is Atomic Structure Lecture 7. All right. See, what all we have studied till now. What all we have studied till now. Right. We have studied your J.J. Thomson model. We have studied J.J. Thomson model. All right. We have studied Rutherford model. Correct. Then we have studied your particle nature of light. We have studied particle nature of light. Correct. Then we have studied your Bohr model also. Then we have studied your Bohr model also. Right. Yes, yes, Srinivas. Good morning, Ilakya. Good morning. Alright, we have covered Bohr model also. Then we have covered atomic spectrum of hydrogen. Correct. Yes. Then de Broglie wavelength, we have covered this also. De Broglie wavelength we have covered. We have covered Heisenberg uncertainty principle. Alright, all these things we have covered very much in detail. Yes, good morning Supriya, good morning. Now in today's class, lecture 7, we need to cover quantum model of atom. We need to cover quantum model of atom. Alright. Yes, we need to cover this, right? Today in today's class you'll be getting introduced to your what are subshells, what are orbitals, what are the properties of your quantum numbers, if you have heard the word quantum numbers, right? All these things we are going to study in today's class. So just give me a thumbs up. Let me see who all are present today. Let me see who all are present today. Just give me a thumbs up, guys. Yes, and let me then start with the main points of your quantum model. Main points. All right. Great, Srinivas. Great. Great. Yes, yes, yes. Great, Ilakya, Rahul. All right, all right. Let us start this. Let us start this with your main points. What are the main points of your quantum model? All right. First of all, who introduced this model? So this model was proposed. This model was proposed by Schrödinger. All right. This model was proposed by Schrödinger. Great Keshav, great Supriya. Yes. This model was proposed by Schrödinger. All right. Now see. Now in many cases you'll be given what is Schrödinger wave equation and all these operator things. All right. We don't need to study that. All right. That is not in our course. All right. What is Schrödinger wave equation? That we not need to study. What was Schrödinger? What did Schrödinger told us about the atom? Right? We need to study that. All right. So Schrödinger. The next point is Schrödinger assumed electron as a 3D wave. Good morning, Kalai. Good morning. As a 3D wave and represented as phi. Phi is what? Phi is wave function. Phi is wave function. Alright. Now tell me in the chat section, is electron a wave? Can electron be assumed as a wave? Tell me in the chat section, can electron be assumed as a wave? Yes, electron can be assumed as a wave because what did de Broglie told you? That every matter has dual nature, your wave nature as well as your particle nature. So electron also has two nature, your wave nature as well as your particle nature. So electron can be assumed as a wave, and its function, like see, suppose, just pay attention here. Now suppose this is your wave. Suppose this is your wave. This is the wave of electron, correct? Alright. So this wave, this graph is being told, is being explained by a function known as phi. What is phi? Phi is your wave function. Phi is your wave function. All right. Yes, phi is defined as your wave function. Now see, what is important for us? What is important for us? There is no physical there is no physical significance. There is no physical significance of psi. As such, there is no physical significance of psi. There is no use of psi. Alright, what is useful for us? What is useful for us is psi square. The square of this function. The square of this function is very useful for us. Psi square is used to find probability. Psi square is used to find probability of electron. Psi square is used to find probability of electron. So psi is not useful for us. For us, psi is not useful. What is useful? Psi square is useful. And what is psi square? It is used to find the probability of an electron. Alright. Now tell me in the chat section, can we find the exact location of an electron? Can we find the exact location of an electron? Can we find the exact location of an electron? No, we cannot. Why? Because Heisenberg uncertainty principle has explained us that you cannot find the position and momentum of an electron simultaneously, right? So we cannot find exact position of an electron. But can we find a probability of finding an electron? Yes. Probability means chances. Alright. So in this quantum model, everything is based on chances or probability, because you cannot find exact position. So you can have a probability of finding an electron. Alright, you can have probability of finding an electron. Good morning, Artri. Good morning. Alright, now see. Now based on this quantum model only, model of atom, you have your orbits. See, you have your okay, let me first tell you this. What is an orbital? There would be a word which is coming. What is an orbital? Orbital. Alright. Now orbital is region of space where probability of finding an electron is maximum. That is psi square. Probability of finding an electron, you can find it with psi square. Psi square is what? Maximum. Approximately 90 to 95%. See, psi square cannot have a 100% value. Why? Because 100% means you are telling the exact position of an electron, which is not consistent with Heisenberg uncertainty principle. Correct? So psi square can have value like 90 to 95% only. Alright. So a region of space, a region where probability of finding an electron is maximum, is your orbital. Alright. Yeah, there is a one announcement at 5 p.m. today. We have our special class. Alright. I've told you before also, I'm again reminding you all, this is absolutely free. Alright? Yes. Yes. Alright. So my name is Nitesh Devnani. Alright. So you guys can just follow me on Unacademy. Alright. Just follow me on Academy. You will get notification of all the free classes. Yes. Alright. Yes. So this is an orbital. This is an orbital. Alright. Is everything clear up till now? Give me a thumbs up in the chat section. Is everything clear? If everything is clear. If everything is clear, just give me a thumbs up in the chat section. Great. Great Shiny. Great Artery. Yes. Alright. Let us move forward. User ID. I think so. User ID is like my name only. Keshav, 90 to 95% means the probability of finding an electron is 90 or 95% only. Alright, probability is 90 to 95%. Yes. Now comes the term quantum. Now comes the term quantum numbers. Alright. Now let me explain you this. Now first of all, these are very important for your NEET point of view. Why? Because questions can be asked from this quantum numbers in your NEET examination. Alright, questions can be definitely asked. Alright, let me first define you this. Set of 4 numbers. Quantum numbers are set of 4 numbers which provide information about energy, shape, orientation and spin of electron. Yes. How many quantum numbers are there? There are 4 quantum numbers. All right. Basically, quantum numbers gives us complete address of electron. Yes, quantum numbers gives us a complete address of electron. What do you mean by complete address? All right. Okay, now see. Yes, now see. Now suppose you want to find where your electron is. You want to find a probability or a maximum probability where your electron is. So see, there is a hierarchy. There is a particular hierarchy. What is this hierarchy? First is your shells. Outermost are your shells. Shells, or you call them as orbits also. Correct? Now inside your shells, you have your subshells. Inside your shells, you have your subshells. Alright. Now inside these subshells, you have your orbitals. Alright. Now inside these orbitals, you have your electrons. Yes. Are you getting my point? So this is a hierarchy. What is the outermost layer? Your shells, then subshells, then orbitals. Then inside your orbitals, your electrons are present. Are you getting my point? Now see, how many quantum numbers are there? 4 quantum numbers. Alright. Now see, your information about your shells, is given by principal quantum number. Alright. Now your information about your subshells is given by azimuthal quantum number. Alright, your information about your orbitals is given by magnetic quantum number. Alright, yes, all these there are these three quantum numbers. Your fourth, this is your 1, this is your 2, this is your 3, and your fourth one is your spin quantum number. Spin quantum number. Now see, all these who designed this quantum model? Schrodinger, correct? Schrodinger was the one who gave this quantum model of atom. All right, now these three quantum numbers, are derived from Schrodinger. These three quantum numbers are derived from Schrodinger wave equation. The equation which was given by Schrodinger, the solution of that equation gives you these three quantum numbers: your principal quantum number, your azimuthal, your magnetic quantum number. But your spin quantum number is not derived from Schrodinger wave equation. Is this thing clear, guys? Tell me in the chat section, is this thing clear? Spin quantum number is not derived from a Schrodinger wave equation. Alright, give me a thumbs up, guys. Is this everything is clear up till now? Yes. No. Again, this orbitals are what? I've explained you before, Keshav. What are these orbitals? These orbitals are region of space where probability of finding an electron is maximum. Maximum value is 90 to 95% only. Alright. Still, we are just saying that electron is present in orbitals. But we are just saying for the sake, like electron is present in orbitals 90 to 95% time. Not, we cannot say it as 100%. Alright. Is this thing clear now? Alright. So spin quantum number was not derived from Schrodinger wave equation. Schrodinger wave equation was not derived. Alright. So see, now see, your principal quantum number is denoted by N. Your azimuthal quantum number is denoted by L. Magnetic quantum number with M. And your spin quantum number with your S. Alright, is this thing clear? Okay. Now let us move forward and let us see one by one all these quantum numbers. We need to study in detail all these quantum numbers one by one. First is your principal quantum number. First is your principal quantum number. Alright? Yes. We will study one by one each and every one. Alright. Rahul, see, there is a hierarchy. First, your outermost are your shells present. Then inside your shells, your subshells are present. Then inside your subshells, orbitals are present. Alright. Just please wait. I'll cover these quantum numbers. You'll be very much comfortable with all this thing. Alright. Don't worry. Yes. Okay, let us start with your first quantum number, that is your principal quantum number. Main point. First point is represented by N. It is represented by N. Alright? Yes. Second point is it gives idea about radius of shell. Alright, energy of electron, velocity of electron, alright, etc. Yes, this n is same as your which we were using in Bohr model. We were using this in Bohr model also. This n is the same as your principal. This n is same as your shell number only. This means your shell number. Alright, so you know all these formula. What was the formula for radius? 0.529 n square by z. So what is this n? This n is your principal quantum number only. Yes, yes, yes. V 2.18 into 10 to the power 6 z by n. I see this. Similarly, there was a formula for energy also. Alright, you guys must be remembering this formula. Do you guys remember these formulas? Tell me in the chat section. Do you guys remember these formulas? Yes. Be active on the chat section. Yeah. Yes, Artery, try to remember it. Those are very important formulas. Great Shiny, great Supriya, Keshav, Vilakya, Rahul. Fantastic, fantastic. Alright. The next point here is maximum number of electrons, present in shell. Maximum number of electrons present in shell is given by 2n square, all right. Maximum number of electrons present in a shell is given by 2n square. This is a formula. Suppose n equals to 1. This is what kth shell. I've explained you k, l, m, n equals to 2. K, l, n equals to 3. M shell, n equals to 4. N shell, correct? Now what are the maximum number of electrons which can be present? Maximum electrons which can be present. The formula is 2n square. Alright. All these are your questions only. Alright. All these are being asked in your questions. So 2 into 1 ka square, 2. Now 2 into 2 square, this is your 8. Now 2 into 3 square. Alright, so this is your 18. Are you getting my point? Now 2 into 4 square, this is 32. Alright, so maximum number of electrons is given by 2n square. Is this thing clear? So this was all about your principal quantum number. Denoted by n. Gives idea about your shell number or orbit number. Alright, gives idea about energy, radius and velocity. And maximum number of electrons are given by 2n square. Alright. Yes. Okay, great. Now second quantum number is azimuthal quantum number. Second shell is your azimuthal quantum number. Alright. Yes, it is denoted by L. Alright. Now what does it tells us? It tells us about subshell. Of in which the electron is present. Alright, it tells us about subshell. Are you getting my point? Alright, it tells us about subshell. Now the important point is, for a given value of n. What is n? N is your principal quantum number. For a given value of n, your L, azimuthal quantum number, can have values ranging from 0 to n minus 1. Yes, let me explain you this. Alright, let me explain you this. Just please wait. Yeah, okay, I'll explain this also. Just let me tell you first this. If L is what? Azimuthal quantum number. If L is 0, if the value of L is 0, it is known as S subshell. If L is 1, this is known as P subshell. Alright, if L is 2, it is known as D subshell. And if L is 3, it is known as F subshell. Similarly, if L is 4, this is known as G subshell. Alright, these are the subshell values. Now, what are the shapes of these subshells? S, P, D, F, these are what? Subshells. What are their shapes? Let me tell you about the shapes. We'll see shapes in our future classes also. Let me just tell you right now this. What are the shapes? S subshell is spherical. Spherical, like your football type. Like your football type. Your P subshell is dumbbell. Have you seen those gym dumbbells? Have you seen those gym dumbbells? Yes, so P subshells are like those dumbbells only. Alright. Your D subshell is like your double dumbbell. Two dumbbells. There would be two dumbbells. I will show you shapes in future classes. I'll tell you about shapes also. Yes. Now F subshell shape is very complex. We don't study this. We don't study the shape of F subshell or either G subshell. We study shapes till your D only. Alright. After that the complexity is very high. So we don't study it. Are you getting my point? Is this thing clear? Is this thing clear, guys? Yes? Alright. Alright. Great Supriya, great artery, great shiny. Yes, yes, yes. Okay. Now let me explain you this point. Let me explain you this point. For a given value of n, for a given value of n, L value ranging from 0 to n minus 1. What do you mean by this? What do I mean by this? Now see. Now see. Suppose n is 1. Suppose n is 1. Possible values of L. What all can be possible values of L? Suppose your n is 1. Your L can have value from 0 to n minus 1. So from 0 to 1 minus 1. So 0 to 0. That means L can have 0 value. Correct? Are you getting my point? Now suppose n is 2. L can have values from 0 to n minus 1. 0 to 1. 0 to 1 means L can have value either as 0 or 1. Alright. Now suppose n equals to 3. Now what all values can L have? Tell me in the chat section. What all values can L have? Tell me in the chat section. What all values? Tell me in the chat section. What all values can L have? Yes. Perfect. 0, 1, 2. Perfect. Similarly, if your n is 4, your L can have values 0, 1, 2, 3. Correct? Correct? Yes. Now see, if L is 0, it means it is was S subshell. It is what? S. It is S subshell. This is S. If L is 1, this is P. If L is 0, S, P, D. Correct? Similarly, S, P, D, F. Correct? Now how do we write it? See, this 1, when it will go with S, it will be 1S. Alright, subshell would be 1S. Now this 2, second shell would go with, first it will go with this. So 2S, then it will go with this. 2P. Alright. Similarly here 2S, 2P, 3S, 3p 3d. Similarly, your 4s 4p 4d 4f. Are you getting my point? Is this thing clear? Tell me in the chat section, is this table clear to all of you? All right. Now see what type of questions are being asked here. What type of questions are being asked here? Now you guys tell me. I'm asking you questions. You guys tell me. Which in which shell D subshell is first introduced? All right, I'm writing it here. In which shell D subshell is first introduced? These type of questions are being asked. Tell me, what should be your answer? What should be your answer? Like where your D subshell first comes. Yes, third shell, right? N equals to 3. See, just check. In n equals to 2, you have only 2s and 2p. In n equals to 3, you have your 3s, 3p, 3d. Correct? Very good, very good. Now, another question which is being asked is, in which shell G subshell would be introduced? Yes. In which shell G subshell would be introduced? Tell me. Yes, Krishanu, good morning. Yes, n equals to 5. Why? Because for n equals to 5, L will have value 0, 1, 2, 3, 4. This is your S, this is your P, this is your D, this is your F, and this is your G. So, in your fifth shell, your G subshell would be introduced. I've explained this artery. Just check here, na. All right. Yes, yes. Very good. Very good. Very good. So these type of questions are being asked here. So again, this was about your azimuthal quantum number. There is one more point. Yes, there is one more point. Let me write down here. All right. See, orbital angular momentum. Is given by, there is a formula for orbital angular momentum, L into L plus 1 under root h upon 2 pi. What is L? L is your azimuthal quantum number. No, Artery, no. That is wrong which you are saying. Alright, L into L plus 1 h upon 2 pi. This is your orbital angular momentum. I will explain you Hund's rule also, don't worry. Alright, this is your orbital angle, or you can write this formula as L into L plus 1 under root h bar. Alright, you can just replace this constant with h bar also. Alright, is this thing clear? Orbital angular momentum. Now just pay attention here. Here a lot of students are being confused. See, what? Tell me, what is the formula for orbit angular momentum? What is the formula for orbit angular momentum? Bohr explained you this, na? Orbit angular momentum is can be calculated by nh upon 2 pi. Alright, this is what? Orbit angular momentum. And orbital angular momentum is L into L plus 1 h upon 2 pi. There is a difference. Between orbit and there is a difference between orbital. Are you getting my point? This thing clear, guys? Let us move on to our next next quantum number. Just give me a thumbs up if this thing is clear. We'll practice some questions also then. Alright, just give me a thumbs up guys if this thing is clear. Your third quantum number is magnetic quantum number. Third quantum number is magnetic quantum number. Alright, first is it is represented by M. It is represented by M. Alright, yes. Gives idea about orientation of electron, as well as it gives idea about orbital. Yes, about orbital. So see, there was a hierarchy. I've explained you this hierarchy, na? I'm again taking you back there. See, this is your principal quantum number, which tells you about shells. Azimuthal quantum number, which tells you about subshells. We have studied these two. Magnetic quantum number tells you about orbitals. Alright? Yes. Okay. Now see, now there is a very important point. Just pay attention here. Value of M depends on L, means magnetic quantum number would depend on your azimuthal quantum number. Alright, and for a given value of L, M can have values from minus L to plus L, including 0. Alright, I'll explain this, don't worry. I will explain you. Okay, now see, suppose your L is 0. Values of M. Alright, suppose your L is 0. L0 means it is what? S subshell. Now what all values M can have? We need to find it. Yes, so M can have values from minus L to plus L, including 0, means minus 0 to plus 0, which is what? 0. Only 0 only? It is 0. So M can have values as 0. Now L is what? 1. Suppose L is 1. This is P subshell. Now what all values can M have? It can have from minus 1 to plus 1, including 0, means minus 1, 0, plus 1. Correct? Now suppose L is 2. This means this is D subshell. So M can have values from minus 2 to plus 2, means minus 2, minus 1, 0, plus 1, plus 2. Is this thing clear? Guys? Yes? Alright? Great. Yes. Now see, now what does M tell you about? Your magnetic quantum number tells you about your orbitals, correct? Now see, this means it has only one orbital. It has only one value, na? 0, 1. Alright, so this means it has one orbital. The number of this orbital is what? 0. Are you getting my point? See, there are three values, -1, 0, +1. So it means it has three orbitals. Values are -1, 0, +1. Are you getting my point? See, it has five values. It has five values. It has five values. -2, -1, 0, +1, +2. Is this thing clear? Now just write this for L equals to 3 means if subshell. Tell me what all values can have, M can have. Tell me what all values M can have. Yes. Yes. -3, -2, -1, 0, +1, +2, +3. Yes. So there means it is like this: 1, 2, 3, 4, 5, 6. Your -3, -2, -1, 0, +1, +2, +3. Correct? Correct? What are these small boxes? The small boxes which I am telling you, which I am drawing is this. So S subshell has one orbital. This means one orbital, only one small box, and there are three boxes, so three orbitals. The P subshell has three orbitals. Your D subshell has five orbitals, and your F subshell has your seven orbitals. Is this thing clear, guys? Is this complete drawing, this complete table which I have made, is this clear to all of you? All right. Yes. Yes. Fantastic. Great Ilakya, great Artery. Yes. Great Shining, great Rahul, great Supriya. Yeah. All right. All right. Now see, there's one more point. There is one more point. Your maximum number of electrons. Sorry, you're not your electrons. Maximum number of uh, orbitals in a shell is given by n square. All right, if suppose your shell is given to you, your first shell, second shell, third shell, and you have to find your how many orbitals are present. So the formula is what? N square. The formula is what? N square. All right, the formula is what? N square. Okay. All right. All right. Okay. Now see. Now see. Now suppose. Now I hope this magnetic quantum number is I've you are able to understand this. You are able to very much understand this. Now see. Now see. Now you need to tell me if n is 3. Suppose if n is 3. All right. Just draw what all values of L, what azimuthal quantum number, what all values of L can have, and then based on the values of L, what all values of M can have. Yes, complete this table. You must be having copy and pen with you. Yes, complete this table. Yes, complete this table. Yes, try to complete this table. I've explained you that if n is 3, your L can have values as 0, 1, 2. Alright. Now M values are dependent on what? L. And L values are dependent on what? N. Alright? Yes. Yes. So now suppose if L is 0, your M is what again? 0. Your L is 1, -1, 0, +1. Your L is 2, -2, -1, 0, +1, +2. Correct? Here only one orbital. Here there are 3 orbitals. Now here there are 5 orbitals. Correct? 5 orbitals. Correct? Now see. Yes. Is this thing clear now? This is correct. I've drawn this correctly. Now tell me how many orbitals? How many total number of orbitals in n equals to 3? How many total number of orbitals? How many total number of orbitals in n equals to 3? Tell me in the chat section, guys. Yes, either you can simply do it as 3 square, which is what, 9. Yes, either you can simply do it as 9 as a 3 square, or simply now you can see also those orbitals. See here, 1 orbital, 3 orbital, 5 orbitals. So 1 plus 3 plus 5, which is what, 9 orbitals. All right. Yes. All right, I've shown you that you can directly apply this formula also, or you can calculate it this way also. Is this thing clear, guys? Is this thing clear? Let us move on to our next uh, quantum number then. Yes. All right. Great. Your last quantum number is your spin quantum. Your spin quantum number. Last quantum number is your spin quantum number. It is represented by S. Represented by S. All right. Now I have explained this before only. This is not derived from Schrödinger equation. It is not derived from your Schrödinger equation. Correct? The spin quantum number is not derived from your Schrödinger wave equation. All right? Yes. Now see. This quantum number is very easy. This quantum number is pretty easy, very easy. It can have only two values. It can have only two values. This is pretty easy. It can have only two values. S can be either plus half or S can be either minus half. That's it. Only two values are possible. Only two values are possible. All right. Now see, for this plus half, we call it as spin up. All right. For this minus half, we call it as spin down. What does spin quantum number tells you? It tells you about spin of electron. Means now tell me in the chat section, where is your electron present? Tell me in the chat section, where is your electron present? Tell me in the chat section, where is your electron present? Tell me in the chat section, where is your electron present? Yes, your electron is present inside your orbital. Your electron is present inside your orbital. Yes. So inside that orbital, electron is revolving in clockwise direction, or it is revolving in anti-clockwise direction. It is explained you by spin quantum number. So if it is spin up, it is assumed as your clockwise. It is assumed as clockwise if it is spin up plus half. If it is minus half, it is assumed as your anti-clockwise. Alright, if it is minus half, it is assumed as your anti-clockwise, means the electron is revolving in anti-clockwise direction. So clockwise and your anti-clockwise. Alright, is this thing clear? Now, another point, another point, another point is an orbital, an orbital can accommodate, an orbital can accommodate maximum 2 electrons. An orbital can accommodate maximum 2 electrons of opposite spin, of opposite spin. All right, now see there, this is your orbital. I am drawing this square bracket, that means it is an orbital. And an orbital can accommodate maximum 2 electrons of opposite spin. Suppose this is your 1 electron. All right, see, spin up, we do this with this. All right, upwards arrow pointing towards upward, this is spin up, this is spin down. All right, now suppose if one is spin up, the other has to be what? Spin down. Correct? Are you getting my point? All right, this is correct, this is correct. Now tell me, is this correct? Now tell me, is this correct? Is this correct? No, this is what? Wrong. Why? Because both have same spin, both have spin up. This is wrong, this is wrong. All right, similarly, if this is your orbital, this is also wrong. Why? Both have same spin. The spin should be what? Opposite. The spins should be what? Opposite. Okay, now tell me, is this correct? Tell me, is this correct? Tell me, is this correct? Again, this is also wrong. Why? Only 2 electrons are allowed in an orbital. Only 2 electrons are allowed in an orbital. Alright. Okay. Shall we do some questions now? Shall we do some questions? I've explained you each and every quantum number in detail. Now we need to do some questions. Now we need to do some questions. Alright? Yes. Let us practice some questions. I have some questions for you all. Okay, great. The first question is, which of following set of quantum numbers is possible? These type of questions are being very frequently asked. There are your quantum numbers, some questions would be given to you, some then you need to find which all are possible. All right, first is n equals to 4, l equals to 2, m equals to -2, s equals to -2. All right, you just need to tell me which set is possible. All right, n equals to 4, l equals to 3, m equals to -3, l equals to plus half. Multiple, there can be multiple answers. There can be multiple answers also. Tell me. Alright, tell me, which all set of quantum numbers is possible? Then I will give you some interesting questions. After this question, I'll give you some more interesting questions. Yes. Which one is possible? Which one is possible? Which one is possible? Yes. Now just look at first option. I'll explain you one. If n is your 4, L can have total values as 0, 1, 2, 3. Yes, so see 2 is written here. 2 is written here. Very good. Alright. Now suppose if L is your 2. Now if L is 2, M can have values from -2 to +2, including 0. Correct? So again -2 is written. This is also correct. But see, spin cannot be -2. So this is wrong. Spin can have only values as your -half or your +half. Alright. Now see, if n is your 4, L can have values as 0, 1, 2, 3. So 3 is written here. Perfect. 3 is written here. Perfect. Now if L is your 3, M can have values as -3, 2 plus 3, including 0. So again -3 is written. This is also correct. Now spin is half plus half. This is correct. Very good. This is correct. Yes. This is correct. Alright. Now suppose your n is 4. So your L can have 0, 1, 2, 3. Here it is 4, it is written. This is wrong. Possible values only can be 0, 1, 2, 3. Alright. Now if this is here only it is wrong, it is wrong. Just you don't need to check it further. Are you getting my point? Now if n is 3, your L can have values as 0, 1, 2. 1 is written. Perfect. If L is 1, M can have values as -1, 0, +1. Again 0 is written. Perfect. Your spin can also have -half. This is also correct. B and D are correct. Very good. Correct. Is this thing clear? Give me a thumbs up in the chat section if this question is clear. Yes. Give me a thumbs up if this thing is clear. No, Keshav, no. Oh, sorry, you're not asking me. Sorry. Alright. Great. Uh, more questions. Uh, more questions. Alright. Question is, a P subshell can accommodate maximum electrons. How many maximum electrons can a P subshell can accommodate? And a P orbital can accommodate max electron. This is your question. Yes, tell me in the chat section. A P subshell, how many electrons can a P subshell can accommodate, and how many electrons can a P orbital can accommodate? Yes. Very good. P subshell means your L is what? 1. L1 means you can have 3 orbitals, correct? I've explained you this before. You can have 3 orbitals. -1, 0, +1. So 3 orbitals means maximum electron means maximum 6 electron. Yes. But in this question it is being asked P orbital. So it is talking about only this one orbital. It is only talking about this one orbital. So any orbital can accommodate maximum what? 2 electron only. Yes. If we are talking about subshell, we are talking about all the orbitals. If we are talking about one particular orbital, that means it can accommodate only 2 electrons. Is this thing clear? Is this thing clear, guys? Is this thing clear? All right. All right. Yes, 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 yes. Fantastic, fantastic, fantastic. All right. Now see, now there is one more topic which we need to study. There is one more topic, and that topic is very important. In our next class, we'll be using this topic extensively. All right. So just attend this class completely, okay? And like this class if you're able to understand everything. Yes. It is energy of electron. Very, very important. Energy of electron. Energy of electron. In this topic, we are going to study two cases. Case 1. First is your case 1. We are going to study two cases, alright? First is your case 1. Alright, case 1 is for single electron species. Single electron species means like your hydrogen, helium plus 1, lithium plus 2, beryllium plus 3. Alright, all these we have seen in Bohr. For single electron species, energy of single electron species depends only on n. N is what? N is your principal quantum number, shell number. All right, this is your shell number. Energy of single electron species depend only on your what? Shell number. Only on your shell number means. And second point is, lower the value of n. Lower the value of n, lower is the energy. I've explained this to you in Bohr also. Means if your shell is closer to the nucleus, its energy is lower. I've explained you this now. As we move away from nucleus, your energy of electron increases in Bohr also. All right. Okay. Now let me tell you this. See, 1s and 2s. If you compare 1s and 2s, now tell me in the chat section whose energy is more, 1s or 2s for single electron species. Right now we are talking about single electron species only. Yes, so 2s has energy more. Why? Here it is n equals to 1, here it is n equals to 2. More the value of n, more is the energy. More the value of n, more is the energy. Alright, yes. Now tell me, 2s and 2p, whose energy is more or they have equal energy? For single electron species, we are talking about single electron species. Whose energy is more or they have same energy? Tell me in the chat section. They have same energy. Why? Because shell is same na. 2s shell is same. No, they have same energy. We are talking about single electron species. Energy only depends on what? N. All right. No, we are talking about single electron species, guys. Value only depends on n. Okay, is this thing clear? Now you have your 3s. Now tell me, between your 3s and 3p, whose energy is more? Now tell me, between 3s and 3p, sorry, 3s and 2p, whose energy is more? Whose energy is more? 3s. Yes, 3s. Why? Because n, value of n is more. Yes, and between 3s, 3p and 3d, what is the relation between 3s, 3p and 3d? All have same energy. Why? Because n sub shell is same. Similarly, 4s, 4p, 4d, 4f. All right, all this is applicable for single electron species, single electron species. All right, all right. Yes, yes, yes. All this is for single electron species. Now, case 2. Case 2. Case 2 is for multi-electron species. Case 2 is for multi-electron species. Now there are lot of more electrons present. All right. Now, energy in multi-electron species, energy depends on value of n plus L. What is n? Principal quantum number. What is L? Azimuthal quantum number. All right. Second point is, lower the value of n plus L, lower is the energy. All right. Lower the value of n plus L, lower is the energy. Simply. But there are some cases where n plus L value is same. If n plus L value is same, if n plus L value is same, then lower the value of n, lower is the energy. All right. See, first of all, you need to just check n plus L value. If it is lower, energy is lower. All right. Now, if it is same, sometimes it would be same. Then lower the value of n, lower is the energy. Lower the value of n, lower is the energy. All right. Let me explain you this with some examples. All right. Suppose you have your 1s, and 2s. All right, let us calculate n plus L for everyone. Let us calculate n plus L for everyone. N plus L is 1 plus 0, which is what? 1. And here 2 plus 0, which is what? 2. Which is what? 2. Correct. Now tell me whose energy is more. Tell me whose energy is more. Tell me whose energy is more. 2s is more. Simply, higher the value of n plus L, higher is the energy. Higher the value of n plus L, higher is the energy. Alright. Now you have your 2p. Now you have your 2p. Let us calculate n plus L. 2 plus, for p, L value is 1. 2 plus 1, which is what? 3. So now between 2s and 2p, whose energy is more? 2p. Yes. 2p energy is more because its n plus L value is more. Are you getting my point? All right. Now see, now you have your 3s. All right. Now here n plus L is 3 plus 0, which is what? 3. Which is what? 3. Now see, n plus L is same. N plus L is same. Now if it is same, if n plus L value is same, lower the value of n, lower is the energy. Now see, here you have your 2, here you have your 3. So whose energy would be more? Tell me. Whose energy would be more? Hello Babita, hello. Whose energy would be more? We have regular classes at 9:30 a.m. We have regular classes at 9:30 a.m. Try to come at 9:30. Whose energy is more? Yes, 3s. Alright, similarly, this is 3p. 3 plus 1. This is what? 4. So, 3p would be having more energy. Alright, now you have your, suppose you have your 4s. You have your 4s. 4 plus 0, n plus L value is 4. Tell me 3p or 4s, whose energy is more? Tell me in the chat section whose energy is more. Tell me in the chat section whose energy is more, 3p or 4s? 3p or 4s? 4s energy is more again. Again see, n plus L is same. Then just check for n. N here it is 4, here it is 3. More the value of N, more is the energy. Yes, 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 yes. Alright. Now then it is your 3D. 3 plus 2, your value is 5. Alright. Is this complete thing clear to each and every one? This is for your what? This is for your what? Multi electron. Alright. There are two types of cases which we have taken. Single electron is different, multi-electron is different. We will be needing this in our next class when I will explain you electronic configuration. Alright. Yes. Any doubt? Tell me in the chat section. Any doubt? Do you guys have any doubt? All clear? In complete class, in the whole class, do you have any doubt? You guys can ask me. Today at 5 p.m. I'm again repeating, we have our special class. This special class is absolutely free. Alright, we will be discussing NEET 2020 analysis, as well as we will be discussing what all can we expect from NEET 2021 as well. Alright, I want you all today at 5 p.m. Alright, Shiny, Atri, Rahul, Ilakya, Supriya, Babita, yes, Kalai, I want you all today at 5 p.m. Okay? Alright? Yes, definitely. Yes. Yeah. Alright. Which platform is good? I'm just asking you that whether you like classes on your Unacademy platform or whether you like classes on YouTube platform, like Unacademy special classes or YouTube classes. Just a feedback from you all. Great Supriya, great Shiny, great Alakia, great Rahul. Yes, Atri. Yes. Okay. If you will tell me, we can also have our we'll also have our morning classes there. You just need to download that app. Alright, just download this app. Thank you, Lakia. Thank you. Yes. Yes. Shiny, yes. I'm just only asking you for this a general feedback only. Yes. Great. Alright. Do you guys have any doubt? Today 5 p.m. special class. Alright, the special class is absolutely free. Yes. Alright. No doubts. Everything is clear. Everything is clear, guys. Yes, fantastic. That is very good. Very good. Alright. So just apply the code Nitesh YT whenever you are planning to buy the subscription plan. You will get 10% off, and if you go for iconic subscription, I can be your mentor there also. Yes. Shiny, you can access those special class in app from your app. Alright, so just like this video guys and share with your friends also. Just like this video and share with your friends and subscribe to our channel also. Alright, and just apply the code Nitesh YT whenever you're planning to buy the subscription plan. Okay, I can help you, I can mentor you there also. Yes. Alright, so I will see you today at 5 p.m. in our special class. I will see you today at 5 p.m. Alright, bye bye. Unacademy, just search my name. Just search my name, Nitesh Devnani. Students have been following me. Alright, just search my name. You can find it, Rahul. Otherwise, just follow our Telegram channel. Let's crack NEET UG English. Let's crack NEET UG English. I will post my class there today. Okay. Okay. All right. Have a great day, guys. Start practicing questions. Start practicing some questions. All right. I will see you tomorrow morning 9:30 a.m. and today 5 p.m. in our special class. Bye bye. Yes, Ilakia. Today there is a special class at 5 p.m. Okay. Yes. Today at 5 p.m. I will send a link on our Telegram channel. Telegram channel. It is Let's Crack NEET UG English. Alright, I will just send my link here on this platform. Alright, okay, I will see you in our special class. Bye. Take care. Have a great day and start practicing questions. Bye bye everyone.